Hello guys, welcome back to Maison African Motives. Still working on governance and having revisions from our past exam papers. We have a question which is from August 2015 on a Porter governor. We had a similar question from the question paper of April 2023. The only part that was asked on that question paper was this one, to calculate the sensitivity of the governor. But now this part has got involvement with a question where you are to calculate the mass of the sleeve, which most of the times you are given, but this time they need you to calculate that mass. Okay, so we are given that a Porter governor has got 346.5 millimeter arms, which support the rotating balls with a mass of 1.2 kgs each. The arms form an angle of 30 degrees to the vertical at a mean speed. We are given the mean speed of 144 revs per minute, and the sleeve mass experience a movement of plus or minus 30 millimeters from the center position. Calculate the mass of the sleeve. All right. So let's just take down our information that we are given. So we have got the arms here, the length of the arms. So normally for me, I just use L to represent the mass, the length of the arms, which is 346.5 millimeters. So if you convert to meters by dividing by 1,000, that's 0.3465 in meters. These support the rotating balls that have got a mass of, so the mass of the rotating balls is given as the small letter. So that's 1.2 kilograms in this case. All right. So these are the rotating balls. So we're given the mass of the rotating balls in this case. Then the arms, they form an angle of 30 to the vertical. So we are given theta, which is our theta in degrees, 30 degrees. And the speed, which is our mean speed, n, is given as 144. That is measured in revs per minute. So from this speed, we can calculate our omega, which is our mean speed also. But this omega is in rad per second. So remember that omega is equivalent to 2 pi n over 60, provided that your n is in revs per minute. Okay, so that means we can calculate omega, which is 2 pi times n, which is 144 over 60. So this is going to give us the mean speed in rad per second of 15.09 796, which is 15.08. It was 15.0796. So that's 08 to the round off. The 9 is going to change that one. So it's going to be a 0. So it's 0.80. Okay, which is in rad per second. Also, we are given the movement, that is the sleeve mass. It experiences a movement of plus or minus 30 millimeters. So in this case, that movement, as for me, I just represent it as D, plus or minus 30 millimeters. And in meters, if you divide by 1,000, that's plus or minus 0.03 in meters. So this is your sleeve movement. All right. So we have got our sleeve movement in this case, which is D. We saw that D affects H1 and H2, which are the heights. And that is the part of what of the sleeve movement. Okay, so with this information, the question is calculate the mass of the sleeve. How can we obtain this mass of the sleeve? And we've got 9 marks for that. Okay, I want us to take back from our formula. Remember from our diagram and the formula that we said before that the mass of the sleeve, the mass of the balls in this case plus the mass of the sleeve times the gravitational acceleration is equivalent to MWH, MW squared H, which you can even start with this side, MW squared, that is MW squared H is equivalent to M plus mg, where M, the small letter M is this one for the rotating balls, and the capital letter M is for the sleeve, which is the dead load. Okay, the dead central load in kilograms. So we need to calculate this. G is for our gravitational acceleration, which you know that G is equivalent to 9.81 meters per square second. So the question is asking you to calculate this M, the mass of the sleeve, which is the dead load. From the information that we are given, we can see that, okay, the mass of the balls, we have this mass. We also, this is the same as this one, we have it. The mean speed, we have the mean speed. This is 15.08, the one that we had before. The gravitational acceleration, we have the gravitational acceleration here, but we do not have the height, which is h. So where are we going to have the height from? We are going to take the angle that we are given and the length of the arms. Why? Remember, guys, from our diagram that I showed about the Porter governor, that we are going to formulate an angle between the balls, these arms, and the vertical presentation. So we are going to be having something of this nature. Remember, this is your arm. This is an arm here. This is another arm. This point. Just depends with the text that you are using, guys. This is our sleeve here. So this is to the horizontal, also to the horizontal. This one to the horizontal. This one is a vertical line. So you've got our heights and so forth, your radius, your radius. This is an arm. This length is the same. This is the one that you are given, the length of the arm, 0, so forth and so forth. And this is the angle that you are given here of 30 degrees, this one, between the arm and the vertical line. So I said, this angle here is the same as this angle. Why? Because we are applying the concept of parallel lines. This is a vertical line. This is also a vertical line. So the angle is the same. Or you can even just take it from, this is a sleeve, this is a vertical line. So the angle between is what? Is 30 degrees. Or you can take it this way. This is a vertical line. So the angle here is 30 degrees. The angle here is 30 degrees. So you can use any part of the diagram to calculate the height, which is this height in this case. So how can we calculate this height? Okay, from this diagram, we can see that if we are to reduce this diagram into a simpler right angled triangle like this, we can see that this is our length of the arm, which is this one, the length of the arm, which is 0.3465 in meters. This angle is 30 degrees. This one on this angle is same as this. I'm going to take this one on top. So this is your 30 degrees here. This is your height h. So you want to calculate this height h, and you have this side and m. So you are using your normal trigonometrical ratios, the application of trigonometry, because what we need is h. H is the only limit for us to calculate m. So we need h. So we are going to apply this from our cosine or cos ratio, because this is our adjacent and this is our hypotenuse. So it means the cosine of 30 degrees from your soccer tower, that's soccer tower there. We have got cos adjacent over hypotenuse. So the adjacent, that's our h, over the hypotenuse, which is the length of that is the arms, which is 0.3465 in meters. So we can use this to calculate h, because this is same as over 1. So by cross multiplying, we can have our h. 1 times h is going to give us h, which is our height. Cross multiply, that's 0.3465 times the cosine of 30 degrees. So this is going to give us h, which is the height in meters. So we are going to obtain our h being something like 0.3. 0.3, something like that, okay, in meters. So this is going to give us 0.3. Okay, from the height that we have, remember the consideration that I was saying to say, this height is going to help us now to calculate the mass. So it depends with what you want to do on this formula. Okay, this is the formula that we are given here. Remember, let me take the formula, this one. This is our formula, and this is the information. So let me just erase this diagram so that, because we have everything in this case. In case maybe we might need to use this information, but for now, I don't think, because we have our height. So in case you have to redraw, no problem. That one is not a worry. We are going to just redraw. So we have our height. So from the formula now, I just want to utilize this space here. So from this formula, we said we can calculate our mass, or you can manipulate your formula. Okay, this is M, the mass of the rotating balls plus the mass of the sleeve into gravitational acceleration, which is equal to mass of the balls into W squared H. So we can manipulate this formula to make M the subject, which is the capital letter M, or we can substitute direct. So I'm just going to manipulate then, but I'm going to substitute direct, don't worry. So you're going to divide by G both sides. So if you divide by G from a change of subject, you remain with M plus M, which is equal to M W squared H over G. So you can transpose the M this side to the other side. So it's going to subtract. So it means we are going to have our mass of the sleeve being equal to, from this formula, that will be M W squared H over G minus M. So you can substitute every value because you have everything here. Now you calculated everything. So that means this can give us the mass of the mass of the sleeve in this case. So you've got the mass of the rotating balls, which is 1,2. So that's 1,2 times omega squared. The omega is your mean speed, which is this omega that we calculated here, 15.08 times the height. You see now the use of that height. So you substitute the height, which is 0.3, everything over the gravitational acceleration of 9.81 minus the mass of the rotating balls. This mass is the same. So you use the mass of 1.2. So this can actually give us the mass that we are looking for, which is the mass of the sleeve, which is going to be 7.145 in kilograms. Okay, so like I said, this was from manipulating from the formula, making M to be the subject. I think we are now used to this formula. Okay, but we can even substitute direct into the formula without having these conversions or making this one the subject and so we can just substitute because we have the values here. M is 1.2, so you can substitute 1.2 plus the mass, which is the one that we are calculating. So it's plus M like this times the gravitational acceleration 9.81 is equal to the mass of the rotating balls, which is 1.2 times our speed, which is the mean speed squared. So this is 15.08 squared times the height. In this case, the height is the one that we calculated from this triangle, which is 0.3. So we are going to obtain, we are going to multiply by 0.3. So you can multiply whatever that you have here. We divide by 9.81, which is affecting the bracket. So you can divide by 9.81. So which means 1.2 plus the mass of the sleeve is equal to whatever that you're going to obtain from this side, which is something like 8.345. So to find M, we can transpose 1.2 to the other side, so it's going to subtract. So it's going to be minus 1.2. So M is going to be 8.345 minus 1.2, which is something like 7.145 in kgs. All right. So this is what we can do. You can just substitute into the formula, or we can just make M the subject. Guys, we are mathematicians. We are doing mathematics. On the other side, all your subjects is all about calculations. So get used to manipulating of formulas to make the letter that you want the subject. Then you substitute into that formula to calculate the one that you're given on the question. All right, so that is from the manipulation, or you can just substitute direct into the formula. Still, it's one and the same thing. Then on 4.2, we are now given to calculate the sensitivity of the governor. That is 11 marks for that. Okay, how are we going to obtain the sensitivity in this case? Okay, remember, I referred also to this one, sensitivity, our formula to say that The sensitivity is given from this formula. So that is 4.2. In this case, we've got our sensitivity, which is equivalent to the mean speed. So you use the mean speed over the higher speed minus the lower speed. So that is going to be the higher speed minus the lower speed. Provided that these are in rad per second, then our answer is going to be in rad per second. So the mean speed is in rad per second, the higher speed is in rad per second, the lower speed is also in rad per second. Okay. So we can even rewrite our formula as the mean speed, which is that omega that we had before from the mean speed, which was in revs per minute, if you still remember, over omega 1 minus omega 2. So I also referred, how do you calculate omega 1 and omega 2? Because omega 1, you already have this. Where are we having omega 1 from? The n that we had before, remember, we calculated omega 1. Okay, I'm supposed to go up. All right. From the n that we had here, we ended up having our omega. So this is your omega here, which is 15.08. But now we need H1 and H2. Okay, that is in this case to help us to calculate omega y. Still on this formula, the formula is the one that we are still going back to this formula. So from this formula, I want us to just make a omega the subject in this case. Okay, this is too much. I just want this part here. All right. Before we made m the subject, because we wanted to calculate m. This time we want to calculate omega. So it still goes back to h, but now we are going to be affected. This one is the one that applies, or the one that uses this h, this formula that we are given. But in order for you to calculate now omega 1 and omega 2, we need to calculate H1 and H2. That is from the sleeve movement that we are given. Remember, there is a sleeve movement that we are given in this case. All right. So that means we are going to calculate that H1. So in this case, I'm just going to make H the subject from this one. I'm just going to make H this. Oh, I can even remove. Let me remove this part, guys, because we have this information. We have this information. I'm just going to write H here, which is 0.3. So H is 0.3. All right. So let me just it right here. So we said H is equal to 0.3 meters. So what I'm saying is that since we are to calculate the speed, because on our sensitivity, there is omega 1 and omega 2. So we can make omega 1 the subject from the formula, because our formula now is going to be mass of the ball, the mass of the rotating balls times omega 1 squared H1 is equal to the mass of the rotating balls plus the mass of the sleeve times the gravitational acceleration, like this. So if you are to check, we need omega 1. So we can make omega 1 the sub, or you can substitute direct into the formula. By making omega 1 the subject, we can simply divide here by mass and H1 both sides, mass and H1 both sides. So this can cancel. So meaning to say omega 1 squared is equivalent to the mass of the rotating balls, the mass of sleeve times gravitational acceleration over mh1. So we can introduce the square root both sides. So that means omega 1 in this case is equal to the square root of this whole part that we are given in this case. So which is going to help us to calculate even omega 2, because I know if this is omega 1, therefore omega 2 is going to be taken from the same formula, but this is going to use H2. So it is going to be mass plus the mass of the balls times the gravitational acceleration over the mass times what? The H2. So that is what we are going to have. If you know how to manipulate your formulas, it's going to be easier. So that is what we must get used to, manipulation of formulas. All right. So like I was saying, H1 is needed and H2 is needed. And these two, we do not have them. If we have these, we can just calculate. And I said they are to be calculated from the sleeve movement. Okay, so remember I introduced before that H1 is taken when we are subtract. So it's going to be this, the height that we had before, which is this one, minus the sleeve movement over 2. So that is d over 2. Sleeve movement, as for me, I said is d, so it's d over 2. So that is going to be h1 is going to be h 0,3 minus the sleeve movement of 0,03 over 2. So this is going to give you h1. With h1 of 0,285, in this case, I've obtained 0,285 in meters because I'm using this one in meters. All right, the h in meters and also the sleeve movement in meters. Everything is in meters, so we are going to obtain this in meters. So we can obtain omega 1 from this information. We have everything, the data that we need to calculate these values. So we are going to substitute into the formula that we are given. All right, so let me just try, okay, to reduce this so that we can see everything. All right, so let's substitute here so that we can calculate omega 1 as it is needed on the formula for sensitivity. So this is going to be the square root of the mass of the rotating balls, which is 1,2. So that's 1,2 plus the mass of the sleeve, which is the mass of the sleeve in this case. That is the one that we calculated here, this one, 7,145. So which means if you got this one wrong, it's going to affect your answers. So that's 7,15. We do not have the frictional force, just like that part that where we subtract the friction. In this case, we do not have. So in this case, we're just going to multiply to gravitational acceleration of 9,81. We do not subtract anything in this case. We do not have. If you are given the frictional force, you subtract it from the numerator. In this case, if you are having frictional force, you subtract that one, but we do not have the frictional force. All right, so that means we are just going to have up to 9,81. Everything divided by the mass of the rotating balls times h1, which is the mass of the rotating balls, 1,2 times h1, which is this one that we calculated from the sleeve movement. So the sleeve movement gave us h1, which is 0,285. So that's your omega in rad per second, which is going to help us to calculate any one. So if we are to calculate this, we are going to obtain 15,4715, which is 72 in rad per second. All right, so that's our omega. So in this case, we have to calculate sensitivity, so we leave it like that. We are not calculating maximum and minimum speeds where you use n1 in revs per minute. So you're just going to use your omega 1 in rad per second. So we are done on omega 1. We move on to calculate omega 2. That is the missing value now on our formula. Okay, where's my formula? Okay, down here on my formula for sensitivity, the missing value is omega 2. Now we have this one, we have this one. So we need to calculate omega 2. Also, just like omega 1, we saw that omega 2 is going to be calculated from H2, which is the height after the sleeve movement. So just like that's like what we saw from our H1, our H2 this time is going to be the addition we are going to add. So, okay, let me show you where we had our H1. Here we had our H1 here. It's now a lot of information. Okay, I had my H1. We had to subtract the sleeve movement over 2 from H. So this time, if you are to calculate H2, you are going to use H plus the sleeve movement over 2. So that is going to give us H2, which is H 0,3, the equilibrium height, plus the sleeve movement, which is 0,03 in meters, because this is in meters, okay? Divide by 2. So you can use H, we can calculate H2 from this way. So this is what is important in your calculations. All right. So your H2, you are going to obtain 0,315 in meters. As you can see, our H2 is bigger than this value. So it is going to give us the lower value for omega 2 because it is in the denominator. So that's why our omega 2 is going to be the lesser value. All right, so you can calculate our omega 2 now because everything that we needed on the information is there. We have everything. The only missing part was H2. Everything we are going to write as it is from this one, but only that H1 is going to be, H2 is going to be by H2. So rewrite everything as it is. that is 1,2. So we are going to have 1,2 plus 7,145 in this case times the gravitational acceleration of 9,81. Everything over mass times the height, the mass of the rotating balls, which is 1,2. So that's 1,2 times this height is no longer this one. This one is, we are now using H2. So H2 is the one that only changed, which is 0,315. So we are going to have our omega-2 in rad per second. That's 14.716 in rad per second. All right. So with omega-1 and omega-2 that we calculated, and also the omega, which is the mean speed, which is this one, the mean speed. Remember your mean speed omega from the mean speed in revs per minute. We calculated omega in rad per second. These are the ones that we are going to use on our final answer. So I'm going to use this omega of 15.08. All right. So that is our mean speed in this case. So therefore, our sensitivity is going to be 15. We said our mean speed 15.08 in rad per second over the higher speed minus the lower speed. So even if you interchange the omega-1 and omega-2, you check the one that has got the higher speed is the one that you use. So the higher speed is at omega-1, which is 15, so that's 15, 472 minus omega-2, which is 14,716. So since these units are in rad per second, it means our answer is also going to be in rad per second. All right, so that's our sensitivity in this case. So therefore, our sensitivity is going to be 19, that's 19,947, something like that in rad per second. All right, so that's what we are going to have as our final answer for sensitivity. That's our question 4.2. So these are the typical questions that you might be given. So governance can actually be asked on a single question, just all about governance. 20 marks for that. So you have to be very, very careful on your calculations, especially when dealing with a Porter governor. The involvement of solving triangles also from the diagram that we had before, the one that I erased, you have to be very, very careful. So that was our question 4, that had 20 marks on a Porter governor. So you have to revise more questions and also know how to take the information that you're given. Take your information properly with the information that you're given. Then you apply your formulas properly. Okay, so that's it, guys, from Amazon African Motives on Power Machines N5. Till we meet again.